Okay, so this is a developer conference, right? And last year the feedback was we want some live coding sessions because we are all developers. So we heard you. And when I talked to David about like what's the bare requirement, like the minimum requirement for a live coding session, he mentioned 2 lines of code. So here you go. I have 3 lines of code in here just to satisfy the requirements. So we are going to create a web application, which is a tic-tac-toe game, and then we will run that. But the more I thought about it, I realized that he invited me on my crime scene to have a suicide in front of 600 developers. So I was prepared for that, and I have slides in here, sorry. Okay, so we're going to talk about event sourcing. I am Shahab, the guy who happened to be a software engineer 20 years ago, still continues on that joyful mistake. At Square, I'm a software transformer, and my main stack is .NET and C#. And I'm also a father of 2 amazing kids, so it is expected of me to tell dad jokes, and I expect from the audience to laugh, because if you don't do that, it will hurt my feelings. I'm not gonna lie, right? And I'm also active in communities, and I'm also a Microsoft MVP. On my free time, this is the only mandatory QR code to scan, and on my free time I'm writing blog posts and creating YouTube contents. You could follow me on these social medias. And I'm not gonna lie, because nobody picked up the phone to scan this code. It hurts, it really hurts. But you have a chance at the end of the talk as well, like to scan this code too. So I also love domain-driven design. And what I like about domain-driven design is bounded context and like having the context. I'm using it so much in my life that the other day my son told me that something funny happened at this school. Don't put any context around that, just laugh. And I was like, why? Context matters, right? Not only it matters in software development, it matters in life as well, right? So in life, it helps us to communicate better with each other, also in the software development, right? To figure out what's going on in certain situations, to have a clear understanding about the words that we are using, right? And it also helps us to avoid serious misunderstandings in life and in software development, right? And so the question was, should I put some context around this talk as well or not? So we are clear what we're going to talk about, right? And what we are not going to talk about. So this is not about event storming. This is not about event modeling. These are 2 collaborative modeling approaches that you should know. If you don't know, I highly recommend that. I also saw some people with Como Camp t-shirts in here. So this is not about that. And also, it's not about event streaming. It's a global architecture pattern that helps you to put your data in motion and communicate between your software components, right? And it's also not going to make us event sourcing masters, because as German-speaking people say, Üben macht den Meister. So practice makes perfect, and we need to practice this over and over and over to be able to use it in production. But it's good to know that something exists in our toolbox that someday, maybe, I don't know, on Monday or some other days, you have another application, and maybe this is like a good hammer to use for creating that application. So we said event storming, event modeling, event streaming, event sourcing. So what are the events actually? The events are facts that are happening in our business and in our domain, and they have meanings and they are immutable. We cannot change those things. So in this scenario, we have a game created, player joined the game, and like a game finished. This is the tic-tac-toe game that we are discussing. And there are different types of events. There are unkeyed events, which are like signaling just a fact in the system. And we have entity events. They are holding all the properties for an event at the given point in time that this event has happened for the entity that this is related to. And we have keyed events. The keyed events contain a key that groups all the related events to each other. So they are sharing a key. So we could store them in locality, and we are able to process them further on if we need to catch all of those things. This is a little bit of a controversial slide, because the events should have a meaning in your business domain. It doesn't matter which type they are. It should have a meaning in your business domain and make sense in the context that you're talking about. And it's very easy in event-driven architecture that we get passive-aggressive and put everything as an event into our system. But not all of the things that we have are events. So the other day, we were sitting at home having lunch together, and my wife told me that we didn't have coffee today. And my kids just ignored what she said, and at first I said, okay, yeah, we didn't have coffee. But further on, when I processed it more, I realized that she didn't want to state the fact of the day as a truth, but she wanted coffee. So it was a command to me that, could you please bring me some coffee, right? So the intention of what she said was different than what I thought. And this is a very big distinguishment between commands and events. With events, we just want to inform the rest of the world about what has happened in the system. But with commands, we expect someone or something to respond back to it, to take actions. This is important. And after I brought the coffee, the kids wanted to play chess. Who plays chess here? Yeah. OK, I expected more. And who knows which game is this? No one? Oh, you know? OK. Interesting, we need to talk. But who knows whose turn is it then? Yeah, nobody knows, right? Because you don't have context. I know, because I created the slides. It's a World Cup championship in 1985, a great year, by the way, between Karpov and Kasparov. And it's black turns. Why do I know that? Because I created these slides. And does that sound familiar? So in our systems, we also tend to store only the latest state of data in our systems, right? And more often than not, it happens that people do not know how we get there, what has happened in our system that we get to this state, right? And we also usually need someone to be attached to that data to describe that whether even this is a valid state in our system or not. So what the chess players did at the time was that they had a notation. When they were moving any piece on the board, they were writing the move on a piece of paper. And so further on, the referees and judges could audit the game and see whether that was a valid game. Everything was valid in that game that has happened. They have even numbered the moves because they wanted to make sure that someone could start from the beginning of the game until the end of the game and apply every move that has happened in that game to make sure that everything is right, right? And also, when someone is more enthusiastic about chess and wants to write a book, they could pick up the same game. They could choose any intermediary state within that game. Maybe some blunders happened from grandmasters, right? And you want to analyze that and recreate that state, intermediary state, and then further on continue either on alternative approaches or analyze it, or, I don't know, continue the whole game and just analyze the whole game in your book. So I was asking why we don't do the same thing with our business systems. Why don't we store the facts that happened in our system and then derive and reconstruct the state from those events? We could create different projections, different viewpoints from those events. Like the book authors, each of them could have their own opinion, but they still could recreate the state and recreate their own opinion and continue on that. So, I think I'm going too fast. I need to save time because I don't want like 500 developers asking questions. It would be hard to answer. OK, to being able to implement that, we need an event store. The event store is a key value database, like any other database that we have, if you think of it, right? The relational database is also a key value database. You have primary key, and you fetch a record with that. So here, the key is the stream ID, or the ID that relates a lot of events to each other. And the value is the stream of events that you are fetching. So in this example, we have one stream, game 1000, game created, two players joined, a cell is marked with X or O, and then the game finished. And then other streams could have their own values. And there are three attributes that we need to satisfy like as a bare minimum. And one of them is that it needs to be an append-only database. So we just can attach events to the end of this stream. Because it is important how the series of these facts happened, because later on we want to create the state from them, and we need to keep the order untouched. And the other thing is that we need a capability to load these streams of events and also make sure that it supports optimistic concurrency, because we don't want two users simultaneously writing into the same stream and making it corrupted. So the process of creating the stream is called a stream aggregation. Sorry, the process of creating the state from the stream is called a stream aggregation. How it works is that if we have a command coming to our system, like fill cell or mark cell as X and O, then a process will be triggered in our backend service, whatever, and then it goes to the event store, fetches the events that are already stored there, and then it gives it to some other entities. It could be your aggregate, it could be any entity. Even the stream is more general than aggregate, so I'm not sure if we should stick with the aggregate, but let's consider it. And then this has a mechanism that could map every event to internal states that it cares about. And these are just some simple mapping functions. They are like, it knows when a game is created, what should be done. It knows when a player joined the game, what should be done, and so on and so forth. And from here on, the rest is like the traditional systems that we have. So we created this state that we needed, and then we could validate whether this command should be accepted or should be rejected. And this is another big difference between a command and an event. A command could be validated to see whether it's valid to continue or not, whether it violates some business rules that we have or not. But an event is a fact in our system. It already happened. We cannot reject that event. So events should not be rejected. And if the command proceeds, it could proceed one or more events, and then we are attaching this event to the end of the event stream, because afterwards we need to recreate the state based on these things. Cool. Show me some code. Let's get to the crime scene. The first thing is my event store. Is it visible, or should I? Yeah. The back? Perfect. So as we talked, I have a couple of methods in here created. One of them is like load the streams, and it accepts like an aggregate ID in this case, which is our stream ID, to fetch all the related events that I have. And then afterwards, I could use this append to a stream, which also takes aggregate ID as the stream ID, and the collection of new events that happened for this stream, and then I could append them. And of course, at the end, I need like to save the stream back to the backing data store that I have in here. And but the store itself just stores the stream. I need a mechanism that makes sure that all these events are applied one by one, and also in chronological order that they happened. So we have this event stream, which I have not implemented. I thought maybe we could do that together. And feel free to shout out if I'm missing any semicolon or not, because I don't want to embarrass myself 5 minutes finding a semicolon. And the event stream also accepts the stream ID, in this case our aggregate, and the store that I could use to fetch the data that I have in here. So let's implement some code, because so far we didn't have anything. So I have events, and I want the store to load the stream of events. It's an async operation, so I'm just putting, this is how we do async in C#, and I don't know why it complains, because probably it needs stream ID. Yes. And if I don't find any events, so Copilot helped me, and then I'm creating a new instance of my aggregate. If I could point to that, here I'm returning a generic type of T, which is nullable, because if I don't find any events related to it, I cannot create any instance of that, and that's why it's nullable in here. Then it would be easier, like have a for each loop or something there over the events, and then I'm telling this aggregate. You remember those when functions that we had in the slides? It could have different names, I don't know, when, rehydrate, apply, whatever you want to name them. What they are doing is just mapping the event into the internal state of this aggregate. So the aggregate knows how to do that. And I'm passing now the event in here, and at the end, I'm just returning the aggregate. Cool. So that's basically the implementation for my event stream to apply the events in chronological order. Then let's take a look into no, wrong one, game events. So I have 4 events in here. Game created, player joined, cell filled, and game finished. Each of them have their own set of parameters that I need to use. And for example, here I'm getting a player ID and the number of the cell that is marked with X or O. And if the game is finished after a move, then either we have winner and loser, or we don't have any, or the game is draw and we don't have anyone winning the game. So what we need to do in here is I have the game aggregate, the game class, and we need to implement the mapper functions in here. And what we are doing here is as simple as just mapping mapping the events to the internal states I have. So in this example, I'm just mapping the ID and name, and for each cell on the board, I'm just doing like the mapping like empty cells, creating empty cells, because the game is just created, right? There's nothing there to be done. And the next ones are more or less the same. So let's say when cell is filled, we are going to mark it as X, or we are going to mark it as O, and the same for the others. See? Game finished. And player joined. So all of them are just mapping functions, except the player joined one. In the player joined one, I have 2 if statements. One of them is this one, and the other one is this. There's a big difference between these 2. The first one is rejecting the event. It is throwing an exception because of some business logic. This should not be in the event handler or event mappers. It should be in the command handlers, where the command, maybe in this case, the command would be join player or something like that. And then this logic belongs there. But the other if is like a mapping logic. It doesn't have anything to do with the business logic of our system. So it's fine to have some if statements in your mapping logic. OK. So now let's implement one of the features that I have not implemented in this system. So it has several features. And the one that I want to implement is this fill cell feature. So this is like a command handler, or more like a facade. So it accepts like a command, fill cell, as we had. And then it handles that command in here. And what it does is we are creating the state from event, and at line 15 and line 16, we are getting the stream from the event store. We apply the events on it, and we have the state of the game at the moment in time. We check if the game is null. We are throwing exceptions. I know maybe some of you are a fan of result pattern or something. This is just what I did for the sake of this talk. We could talk about that later outside, right? And we have the game, and then we are passing it to the domain object that is responsible to make sure that whether this is a valid move in our game or not, to satisfy the requirements that we have, and then storing the new events that might be exposed in here, and storing them at the end of the stream, and then saving things. So what is not implemented is actually inside this play command. So we will see this guard against invalid prerequisites like momentarily. But what I'm doing in here is just after I made sure that the command can proceed, I am applying a new event. So I'm saying that there is a new event exposed or needs to be exposed, and it is like cell field. So the move, the command was successful, and then it goes into detecting whether someone has won the game or not, or either the game is finished with a draw or something like that, right? And if we take a look into the implementation of this, for example, forgetting about the logic in here, it applies another event in here. So it could happen that after someone plays one cell or something like that, both the cell is filled and the game might be finished by having a winner or not, right? Like if I have 3 X's in the same row, so the last one exposes 2 events in our case. We will see that in action too in here. Let's, what am I doing? Yes, guard against invalid. And here I'm just validating whether this command could go forward or not. So is the game finished? Is it my turn to even play? Is the cell already filled or something like that? So it is all about validating the logic. And so far, what we did is just wrote some simple functions that are just doing more or less mapping, right? And what would be easier than just testing pure functions that are just getting some input and exposing some output or producing some output for us? So let's take a look to see how we could test these kind of functionalities in our system. So for the same command, I'm calling it specifications because I believe that the tests should kind of be the living documentation of your system and like specifying exactly what your system is doing. So I prefer spec over test for naming and like attitude-wise as well. And so taking a look into one of them, for example, cannot play a game without players, right? So what I expect is the given part of it. So in the given part, we say what the state of the system should be before we issue a command on the system, a new command on the system. So in this case, I'm saying I just need a new game to be created. I just need a new game, nothing else, right? And if someone tries to make a move on this game, it should be rejected because no players has joined the game. There's no one on the sitting at the board to play the game. So this is the situation. For the next one, we have like the same thing. So we have a new game needs to be created. We have 2 players joined the game. And then game can be played by joint players. And then someone else, I don't know, somehow a 3rd player wants to issue a command against our system. And we are making sure that this is also an invalid move in here. So let's take a look into a more complex situation where, I don't know, we have someone winning the game. It is basically the same. So I'm considering a new game, 2 players has joined the game, a couple of cells are played, and then a new move is made on the board. Then I'm expecting here, it's the then scenario, I'm expecting 2 events, cell filled and game finished to be issued. And all the tests are more or less the same as this. So I would like to show like a demo of that. Maybe we could have it here. Hopefully the Wi-Fi is working. Oh, I'm great with front-end stuff, you see that? So let's create a game in here. So I'm creating a live demo. The players are joining. And you see, we already have the list of the events that are happening. So this player plays the other one. And the first thing is that if I refresh the page and I join the same game, I'm expecting the state to be created. So this is one scenario, like it could happen, and you want like to recreate this state. And we will see that like how we did, because so far what we talked about is just the right side of the application, how we could write to the stream, how we could go further. But there is another part which we could fetch the data from that, and this is one of the scenarios. So let me finish the game, because I enjoy playing games. And if I'm fast enough, after clicking that and refreshing the page, I could show you something. So the live demo is here, and it means that it is active games, right? If I refresh again, it is gone. Let's take a look into those two scenarios that we have. So I have this load game state feature. It is as simple as this. So I'm getting the game instance from the database by fetching all the events, applying them one by one, and then I'm exposing the internal state to something understandable for the external system, whatever it is. In this case, I'm just returning an array of strings with X and O, and then I'm mapping that on the front end to create the state. For the other one, the problem was that this is a synchronous way of creating the state, so I always have the latest state in here. For the active games, what I have is that I created the state asynchronously, so it could happen that the read model for me is not up to date with the latest state of what has happened in our system, because it's eventually consistent, and that is something that is happening in our lives as well, right? The whole universe is kind of eventually consistent, and we cannot defeat the laws of physics. I mean, we could maybe get closer to the speed of light, but it's something hard to do that. So let's see how the implementation of that looks like. So I have a model. I named it Active Game List Projection, and it is the same as my aggregate that I have, more or less. So it says I'm interested only in two events. I'm interested in game created, and I'm interested in game finished. The rest of the events that are happening in this stream, I have no interest in that, because when a game is created, I want to add it to the list, and when a game is finished, I want to remove it from the list, right? And these are the mapping functions in here. Then I have a projector, whatever you want to name it. I have some piece of code that is responsible to fetch all of those events as they are happening. And I'm using a left fold projection in here. So what does that mean is that I have an initial state, whether an empty list or something that already is populated and is stored at the database, right? I'm fetching that. And then as the events are coming into the system, I'm applying those events into this state, and I'm creating a new state, and then I'm storing this new state in the database, right? And it's as easy as a for each loop again, and I'm interested in the JSON type, and if it's game created, I'm calling the function related to that. If it's game finished, I'm calling the other function, and then for the rest of it, I'm just logging something. If something has changed, I'm upserting this new list to the database so the users could see the actual data at the end. So in my notes, it says that I should go back to the slides. Let's see if I'm correct or not. How can I? OK. So I used Azure Cosmos DB to create the event store behind the scenes, and I created it like manually to make sure that that I'm appending to the end of the stream, that I'm fetching the data properly, the concurrency mechanism is handled or not, right? But I would not recommend that you start doing like these kind of things, because there are already tools out there that you could leverage to make sure that you are ready for implementing something for the production. And these tools are like battle-proofed, and you could just use them to implement what you need to do. And so far, it sounds like easy. Like with event storming, it's just a bunch of functions we're writing and mapping and just like validating the command, right? But there are also challenges out there. like eventual consistency that we see. What if the projector cannot catch up with the current state of the system? What if I want to have a new version of the event that I'm producing? What if the stream that we are developing getting longer, getting big and big, like so big that we cannot like populate the current state from that, right? And these are challenges that there are solutions out there for them. And this is like a new modeling technique that we just need to learn and like practice to make sure that we are could apply them properly in our systems, right? But there are also benefits to them. So, for example, caching is like cache invalidation is one of the two hard problems in our software in our industry, next to all the soft problems that we have, right? And with this, if every state has a URI, for example, we don't need to invalidate the cache because this state always have the same value, right? Or events, it tells us about history, right? The history is something that we are interested in. If we are interested in, right? If it's not like my search history. So if you are interested in what has happened in your system to get there, if you want to answer those questions, if you want to have audit, if you want to analyze your system, and if the data is important for you, if you want to be flexible for the future requests that are coming to systems, maybe this is like something that you need to consider next time that you want to implement like an application. For me, there are two other things that stands out from the other features. It's that the first thing is that it is as close as we can get to the real model, because the events are just the facts that happened in our business. The stakeholders understand them. We could talk about them, and it just makes every communication more clear. And the other thing is that we are free from the restrictions of the data stores. Like consider all these nitty-gritty things that we need to do with the ORMs to make sure that like our models are mapped properly to the relational databases that we have behind the scenes. So you could here use anything that you want. If you are interested in the source code and you want like to try it at home for yourself, here is the GitHub repository. You could clone the repository. There's also a link to the Java version of that. If a colleague of mine, Daniel, sitting here, take the effort to create that version, if you are interested in. And of course, I also promised David to tell a dad joke, and that's for him. Do not use Fortnite as a password because it's too weak. And if you want to get in touch with me, please, this is your last chance to scan the QR code. And yeah, I'm happy to answer any questions if there is any. Back to you, Julian.
You're actually taking questions now?
Hmm?
You're actually taking questions?
I mean, you tell them to think twice. So I give them the chance.
Give them the chance at least.
No,
okay, who's brave enough to ask Shahab a question? Amazing. I'm gonna try my best. Yeah, almost. See?
He's actually twice as me, I think.
Huh?
He's actually like twice as me. I can.
Okay.
Please.
When to use and especially when not to use event sourcing, because most of the things we can have with more trivial way of development plus a very good audit log, isn't it?
So I think the biggest thing for me is that in the trivial, like the audit thing is out of the box in here. Even though for auditing you need to add more things to make your system observable and visible, right? And the thing is that it enables, from my experience, it enables me to be more flexible when new requirements are coming into the system, to be evolving the system. And also when it comes to what happened to the system that we get there, not in every system you need to answer that question, right? Sometimes you don't really need anything about the history of what has happened in here. So in those cases, you shouldn't use that. And another deciding factor that I saw, like event sourcing fails or succeed, is kind of a thought process that needs to be shifted to another way of thinking about developing softwares, and it needs like experience in your team. So if you don't have people still in your team that you do not know this, it would be a lot of overkill.
Okay, thank you.
More questions for Shahab. There's one over there. I can see one over there. Wow, perfect throw.
Okay, so thank you for the presentation. I have a question about how would you approach event sourcing in distributed systems when the aggregate might be spread throughout multiple applications and they do not necessarily have the access to the same event store because, for example, they are hosted on different environments. Do you think this is still feasible or maybe it's not the good pattern to choose?
Yeah, that's a great question. I want to ask, how do you expose your relational databases to other systems to query them?
No.
Yeah, it's the same thing. So when it comes to event sourcing, we have, even though all of them are events, right? In event-driven architecture, we also publish events to the Kafka streams, right? There is a distinguishment between internal events and external events. To give you an example, consider we have a booking application or something like that, that we ask the users that whether we could track their GPS to make sure that when they are in the vicinity of the hotel, we get everything prepared for them, right? Every GPS signal that comes to our system is an event, but it's not something that my system is interested in them until they are in the vicinity, and then we are changing that event into something meaningful for the business domain of this tracking system, right? And then it changes into something that, I don't know, the customer entered the vicinity, and then we are triggering some businesses in our business flow, right? It could have been implemented then internally afterwards by event sourcing or by relational database traditional way, right? But this is the distinguish that I make. So if you need to expose something for the external world, then you might also treat it as as the API of your system as well, right?
Thank you.
Perfect. We can take one more question. There's one in the back right there. Amazing.
Hello, hello. Test. Thank you for the presentation. It was very nice. I just had one question. If you have to recreate the state of a certain aggregate or a stream every time when you try to interact with that, doesn't that lead to performance issues or any concerns about that?
Yes. So I think whenever we are dealing with a database system, we should consider performance issues, right? If we learned a lot of techniques for relational databases to denormalize the data, and when to normalize and when to denormalize to make sure that data is performant, right? Here we also have technical techniques to make sure that we are not hitting a performance issue in here. Usually when you have, I don't know, hundreds or thousands of events and recreating the state from them is not problematic. If you have more than that, maybe we should think again, maybe we have designed something wrong, right? So one of the techniques, for example, is having snapshots on some intervals, and then from that snapshot continuing to creating the state with the events after that snapshot, right? Another thing is that your streams maybe should represent the processes in your business, because the processes usually do not have that much events going on, and it could be easier. So there are techniques out there to help you to overcome a performance issue if you have any, but those are the key principle. If you hit a performance issue, then think about that.
Amazing.
Thanks.
Thank you very much, Shahab.
Thank you.